This video explains how to compute ES, EF, LS, and F. First of all, we use very simple example. Suppose we have A node one time, it takes 1 minute or 1 day, 1 week, and B node, it takes 4 weeks, and C node, it takes 2 weeks, and then finally we can complete D node. D node, it takes 3 weeks. So we use certain time unit. I mean, we can use a week or month or whatever time unit is fine, but we have to use consistent time units. So A takes 1 week, B 4 weeks, 2 weeks, and 3 weeks, and so on. And we have this kind of predecessor and the successor relationship. Means as soon as you finish A, then you can start B, and at the same time you can start C. And for D, you have to complete the B and C. If you finish only B or only C, then you can start D. So you have to finish A and B and C to start D. That's basic assumption. And first of all, we can start ES. I will denote ES here, ES. So for A, we can start right now. Right now, timeline is 0. Then basically, EF is equal to ES plus duration. So this is a very simple idea, right? So what is EF? What is earliest finish time? What is finish time? 1. You have to finish 1. So you can start right now, timeline 0, and then you can finish 1. And if you finish A, then you can start B, also you can start C. Then what is ES for B? ES B should be 1, and EF simply 5. And also for C, ES will be 1. So you can finish A, then you can start C. Then that's why ES earliest start time is 1. What is EF? EF will be 3, simply. And now D case, you have to finish B and C. Even if C is finished earlier, 2 weeks earlier than B, but we have to wait until B is finished. So that means, what is ES for this case? ES is 5. And what is EF? EF is 8. So especially when you take into account this to compute the ES, you have to take into account what this is predecessor. So you have to basically, ES is maximum number of predecessors EF, right? So this is principle 1. Principle 1 is EF simply. EF is equal to ES plus duration. It takes more time duration. Second principle, if you have not only one single predecessor, if you have several predecessor, you have to take a maximum number of all predecessors, just previous predecessors EF, right? That's principle 2. And now, if you compute the ES, EF, earliest start time and the earliest finish time, you can move forward. And then now, you can move back from here. So when should you finish, when do you have to finish this one? So the latest finish time should be 8. So for the last operation, EF, LF should be equal. This is kind of a new principle. And simply, what is LS? LS is LF minus duration. So this is principle 3. So for this, what is LS? LS is equal to 5. So you have to finish 8 as late as possible, right? So then you can finish this task D in 8 as late as possible. And back to here. So now D can start at 5. That means what? when can you finish C? So you can finish LF. LF is previous one. LF is what? 5. So you will take into account this previous LS. And also what is LF here? LF, again, you have to take into account this number 5. And then now what is LS? LS simply you subtract duration, then this will be 3, and this will be LS will be 1. So now you have to move back, and for A you have two successors. So actually you have two LS numbers. So you have to take into account two LS numbers. This LS number will be, one of them will be LF. So what is LF for this case? For B, you can start as late as possible. When? 1. So how about C? You can finish as late as possible, 3, right? But C, for C is okay, but B, you have to start 1 as late as possible. That means you have to take minimum number of these, so that's why LF for this one is 1. So then again, principle 4, what is LF? LF is equal to minimum number of, earliest time, minimum number of all successors LS. That's principle 4, right? So then you can compute LF, and then you can compute LS. What is LS? LS is 0. So now, based on all these ES, LF, finally you have to compute the slack number. What is slack? Slack, you have LF minus EF or LS minus ES. That's difference between earliest time and the latest time, or latest finish time or earliest finish time. Then you can compute the slack time. So for slack, so we just compute this slack number very easily. How about this? Slack number is slack equal 0, right? So you can subtract this number. How about this? This again, slack number equals 0. How about this? This is also slack number equal 0. How about this? Slack is equal to 2. Means operation C, especially this operation, has some slack, means it's available for this operation C, has some slack time. That means they can delay this operation C for 2 durations. But others, all slack 0 case, all slack 0, that means what? You connect all slack 0 path, that is your critical path. So it means there is no slack time, means it's very tight. You cannot delay all these operation A, B, D. This is a critical path. So this is a very simple idea. So first, when you move forward, and then you can compute the ES, EF, and when you move back, roll back, and then you can compute LF first, and then you can compute LS. And also you have to take account maximum number of predecessors EF to compute the ES, earliest start time. Also, when you compute the LF, then you have to take into account the minimum number of all successors LS. So that's kind of some basic ideas how you compute EF, LS, LF, and LS, and slack numbers.